In this video, we'll be looking at the properties of equality. By the end of this lesson, you should be able to solve a two-step equation and justify the steps of solving the equation using properties of equality. So let's take a look. We have a table here of our properties of equality. So let's look at the addition property of equality first. This property says that we can add the same number to both sides of an equation. So an example of what that looks like is if I have the equation x minus 3 is equal to 5. The addition property of equality says that I can add 3 to both sides in order to solve for x. When I do that, my inverse property says that negative 3 plus 3 is equal to 0, and I get rid of that. X is equal to 5 plus 3, which is 8. Another example, if I had y minus 5 equals 2x, in order to solve for y, I can add 5 to both sides. Again, minus 5 plus 5, my inverse property says that goes away and equals 0. Y is equal to 2x plus 5. Notice for my addition property, I see subtraction and I have to do addition. And that is when I do my addition property of equality. And it has to be done to both sides of the equal side, both sides of the equation. My subtraction property is going to be similar, except I'm going to subtract the same number from both sides of the equation. So now, if I have the example x plus 3 is equal to 5, the subtraction property says I can subtract 3 from both sides. Again, my inverse property says that that is equal to 0, and I can cancel it out. X is equal to 2. 5 minus 3 is 2. Another example would be if I have y plus 3x is equal to 8. Again, I see addition. I can subtract 3x from both sides of my equal sign. Negative 3x, positive 3x, minus 3x cancels out. Y is equal to 8 minus 3x. My multiplication property of equality says that we can multiply the same number to both sides of an equation. So an example of this would be if I had x divided by 3 is equal to 5. My multiplication property says that I can multiply both sides of the equation by 3. In this case, I have 3 in the numerator and 3 in the denominator, and those can cancel out. Same thing. That's my inverse property. They cancel out. I'm left with x equals 5 times 3 is 15. Finally, my division property of equality says that I can divide the same number from both sides of an equation. What I do to one side, I have to do to the other, just as I've done before. So an example here would be if we saw 3 times x is equal to 12. I would divide both sides of my equation by 3. My 3's, again, inverse property canceling. X equals 12 divided by 3 is 4. We use these properties to simplify and justify equations. So let's take a look at what these words mean. To simplify an equation is to make it simpler, easier, or plainer. Okay? When we simplify an equation, we combine like terms. We combine, we put them together. We combine like terms when we're simplifying an equation, okay? This is compared to if we are justifying an equation. We want to say the reason why something is correct. You want to explain why an answer occurs the way it does. So as we go forward in class, we're going to look at some examples, and you may have to simplify or justify using these properties why you're doing the steps that you're doing to solve an equation. Let's look at some more properties of equality. This is on the back of your notes, so go ahead and flip your notes over. Our first one that we're going to look at is the reflexive property, which, if you've heard of the word reflection, can help you remember the meaning of the reflexive property. This property says that a number or variable or expression equals itself. So the reflexive property says that x is always equal to x. Another example would be 3 is always equal to 3. Reflexive property says we have one equation equal to itself. 3 is always the same as 3. X is always the same as x. My symmetric property says that an equation can flip or reverse sides. So if 3 is equal to x, then x is equal to 3. Notice how I just switched sides. That's your symmetric property. It just switched locations. If 3 is equal to x, then x is equal to 3. Another example would be if 3 times the quantity of x plus 2 is equal to 3x plus 6, then 3x plus 6 is equal to the quantity of 3 times the quantity of x plus 2. Notice how, again, my equations on either side, my expressions on either side of my equal sign flipped. That is your symmetric property. Let's take a look at the transitive property. The transitive property connects two equations into one equation. So for example, if 3c plus 2 is equal to d and d is equal to 5c, then 3c plus 2 must be equal to 5c. This is my transitive property. I'm taking two equations and connecting them into one equation. Notice that both 3c plus 2 and 5c are equal to d, so that means they are equal to each other. Let's look at one more example there. If x equals y, and y equals w, then x is equal to w. Again, x is equal to y. So x is equal to y, and y is also equal to w. So we can kind of skip that middle step and say that x is equal to w. These are equal to the same thing, so they're equal to each other. That is our transitive property. And lastly, substitution. Our substitution property says that we can replace or plug in something that's equal. So an example of that would be if y equals mx plus b, and m is equal to 2, and let's say b is equal to 3, then y is equal to 2x plus 3. Notice for my substitution property, m, was equal to 2, so we replaced m with 2 in our final equation here. B was equal to 3, so we took where the b was and replaced it with a 3. That's our substitution property. Let's look at one last example. If y equals 5x plus 2, and we have y is equal to 8, then we can say that 8 is equal to 5x plus 2. Again, we said that y equals 8, so we replaced y with 8, and our final equation now says 8 equals 5x plus 2. We use that substitution property. That's the end of our video for looking at properties. We will use these in class to, again, simplify equations and justify why something is correct as we go forward.